Hi, and welcome back to Power Management Validation How-To video series. So we saw quite a few things in my last video series that I created. And for this particular video, I'll be showcasing how to do PMIC ganging. So what ganging is, this system allows you essentially to connect everything in series or in parallel to get either more voltage or current. For my particular example, I will be connecting everything in parallel to get more current. And now for anyone that followed me since the first video, you should have all the software, everything already ready to go. If this is the first video you watching and you did not follow the first video, I'll give you a quick what's happening. So you would go to this open source GitHub library that we provide. And inside here, I was working with LabVIEW. So the particular example I'm working with is LabVIEW, but it's also available for Python, and the steps are very similar. For here, you want to make sure if this is something new you're starting out, you want to go through this README file and see the key features. So for ganging specifically, we'll be checking single point channel ganging, sweep channel ganging, and efficiency channel ganging measurements. I'll do only a single one, which is efficiency, just to show you how to get to that. And so there's some hardware dependencies, obviously, and there's software dependencies. So you want to make sure that software is pre-installed. Since I did this since day one, everything is installed, I'm ready to go. And after everything is ready to go here in this section, you also want to go to releases and download here this asset here, this package of these examples essentially, which includes all your the single channel and then ganging channel examples. And this goes and downloads everything through Package Manager, which is the easiest and the best and my recommended way to do it. So let's go get going. So everything again is installed on my system. So next I want to cover is the interface itself. Okay, so here I have the interface. So for my interface, I have PXIe-4151, which is the power supply, connected to another one in parallel. And then I have a PXIe-4051 connected to another one in parallel to get to be able to do a higher load. So my DUT is shown here, as you can see in the diagrams. For the interface is shown here. Now, if you are connecting to a different DUT, the interface you would have to change is obviously to match your DUT, right? The connections for the E-load and power supply might stay the same if you're doing more current. And one thing to note, in my past videos, I was also using the digital pattern instrument to control my registers. For here, I don't need to control my registers. I'm just utilizing my power supply and the E-load. So I don't need to do that. But if you're interested in setting up that and using semiconductor device control, you can go check out my previous videos to see how I did that. Now, let's get started with InstrumentStudio Pro. So I am using the remote system. So I'm going to go and start InstrumentStudio Pro. So it might take you a longer time to start on the first go. So it's going to preload everything, all the examples and all the plugins that we downloaded here. So while we wait, we'll do the efficiency measurement again. And here we go. So okay, so first it's preloaded efficiency, but the way to go about it is you would go here. If it didn't load it for you, you click here, you go to manual layout, and then you're able to select here, the measurements will show up. So this is a single system measurements, and then we have ganging stacking measurements here. So here's efficiency, right? And you can go and select clip, create large panel, and click OK, and this will create it, and then you can rename this to efficiency or anything you want to have it here. And then there is minimum setup. So we have a source config. So we need to select the source of which is our power supply. So here I have different SMUs. This is a system that I'm borrowing. So this particular system clearly has a lot of hardware. So you will want to select 4151, a slot 2 in my chassis, and then you need another one since it's in parallel, right? So you want to connect and maybe slot 4, I'll select, and then load config. You also want to connect to E-load. So here my eload is called eload slot 2, and you can rename this to NI Max, right? So you can change the naming for this particular system that I'm using. This is the names that it was set up. And then the next one is eload slot 5. So for you, again, it might show up very differently. So once you have everything set up, you might want to change these. So for me, voltage start level is 6 volts, voltage stop level is 14, number of points I'll measure is 4. It's just to showcase how to get to the step. Now for your DUT, if you're using different DUT that's different from mine, you'll obviously this will vary for your DUT particular settings. Now once you have this set up and you're ready to go, essentially all you have to do is just click run. And then we should be able to see 4 graphs come up on here and allow us to see the efficiency of our power supply. So here we can see that efficiency is pretty good at 89%, and it seems like it peaks out at about 16 amps. So that's pretty good efficiency considering what I'm measuring. So this showcases how to get to InstrumentStudio Pro and get to the first and perform your first type of measurement with a system that is set up in parallel. I will showcase another video for getting how to go to automation through the InstrumentStudio Pro and test it. But for now, thanks for watching and hope you enjoyed it.